to our current situation. Particularly, I'm talking about COVID-19. So today we are going to discuss about epidemiology and see how it is important to be able, or how it is useful in assisting persons who are encountering a pandemic. So to begin with, I will not wait for the latecomer because I've been able to put an app that a person can be able to join on their own without necessarily me approving or approving them to enter. So this is introduction to epidemiology. I'm your course lecturer, Mr. Jonah R. Nyachai. So prior, I was able to send you the course outline or what is expected of you to learn. So I will not waste a lot of time, but you're expected to go over it, which is in your WhatsApp group. Please find time, read it through, and see what are your key competencies that you require. So for this lesson, we are going to introduce, where we are going to define terms like epidemiology. We are going to describe history of epidemiology. We are going to list the uses of epidemiology. We are going to describe the basic epidemiological methods, and then we are going to describe the tasks of an epidemiologist. And then we are going also, there are other objects. So I've been able to arrange this session into two parts so that we can be able to go and meet all our objectives. So epidemiology is a very interesting unit, because epidemiology for a student, probably at your position now, some of you may, for them, it may mean it is the worst taught course in medical school because of complex or practical mathematics that you may require to know. For a clinician, epidemiology has another definition where a clinician may be able to see epidemiology, the science, as the science of making obvious obscure. A statistician also see epidemiology in another dimension, where they see is a science of long division, where you have to calculate tedious mathematics for you to be able to generate meaning, particularly for analytics. And then for an average person, it is just the study of skin disease. So you see, there are a lot of definition. So my question is, for you, how or what do you think epidemiology is, or what does it mean to you as a student who is, or who has the opportunity to learn epidemiology in class? So maybe if we can be able to talk about the etymology of epidemiology, basically we break down and see what that means. So epi, it means upon. Demos, we mean people. Logi, we mean the study. So when we combine all this etymology, then we can be able to have a very, very good definition of what epidemiology is. So again, we also have some fundamental epidemiological axioms that we as epidemiologists believe in. Those beliefs that we carry in epidemiology, we call them epidemiology axioms. So if you go to your English dictionary, you'll find that there is a definition of axioms. And axioms, basically, it has been defined as a statement or basically prepositions which are regarded to being established, accepted, or self-evidently true. So they are just statements which are thought to be true. So in epidemiology, we believe that diseases or other health events do not occur at random. There is nothing like a disease that comes on its own or occur at random. That is what we believe. in epidemiology or as epidemiology students. We also have the belief that diseases or other health events have causal, meaning it has a cause, and preventive factors that can be identified. So these basically axioms are basically assumptions. They are basically our assumptions. They can also mean what? Prepositions. What in Kiswahili usually say kudhania. So what the epidemiologist dhania, or what the assumption is, they assume that disease do not occur at random, and those diseases have a causal or a cause and have a preventive factor which can be able to be identified. So you need to put that in the back of your mind, that is the belief that guides epidemiology. So how do we define epidemiology? How then do we meet our first objective? What is epidemiology? We can say that epidemiology is the study, because we have said ology, of distribution and determinants of health-related states or events in specified population, and application of this study in the control of health problems. So that is what is epidemiology. The study of distribution, we are looking at the distribution in terms of regions, we're looking at distribution in terms of time, and also determinants. What are these factors that can be able to cause disease? So the study of distribution and determinants of health-related status or events that specified population, and application of those now studies that we have got to be able to control health problem. So that one was defined by last 1988. So in other words, the key words that when you are asked to describe epidemiology, the key word that has to appear is the study, number one, of distribution and determinants of health status and events in a population, and the application of those study in helping what? In helping or in control of health problems. That is the basic thing about epidemiology. So, in our definition, we have distribution and determinants. Maybe you are asking yourself, when we are talking about distribution and determinants, what do we mean? It must be ringing a bell, or you may be asking yourself that in our definition, distribution is featuring so highly among our definition. So what do they mean? So when you're talking about distribution, when we're talking about distribution, we are talking about basically types of epidemiological study. So distribution, it could be descriptive or it could be analytical, just like research. So in descriptive epidemiology, we are talking about the who, the what, the when, the where. We are just basically not seeking to get any meaningful information from that information or the study that we obtain through epidemiology. So we're just describing who, what, when, where did we find the condition, who was responsible for the disease, how did it occur, and so on. And then under descriptive, we are also talking about frequency and patterns. Frequency, we are talking about maybe we have COVID-19 in Kenya. We have a particular number. Right now, we're talking about numbers in excesses of 30,000. the rate of infection and mortality. Our infection in COVID, let's say as the case of COVID, we are talking about at one point we had an infection rate of about 5.2. We are talking about risks. We are just describing. You saw these policies are actually changing. First, we talked about masks. We talked about hand washing, and so on. So also talking about the patterns, you have been able to see like our minister has actually been giving us the time, the place, and person. Like say they say in Mombasa, to show the place, what is their prevalence? What is the pattern among the males and females? You know, so basically they are using the descriptive epidemiology to describe what? The distribution, which is in the part of epidemiology. So from there now, when you get this who, what, when, you talk about the frequency, you talk about the pattern, you can be able to generate a hypothesis. And hypotheses are statements which have to be verified. You can be able to say, like in the case of Kenya, more males are being infected than females. You understand? So that is called descriptive epidemiology. On the other hand, we have analytic epidemiology. Yeah, as determinants. We are now analyzing and finding why and how, or what is causing that condition. So in analytical epidemiology is the second part of our definition. So we have said in distribution, we are basically doing what? Describing. Describe. No analysis or link is being established. And then on determinants, we are talking about some element of analysis. Yeah? We're talking about some element of analysis. We're talking about why. We're talking about how. We're talking about causes and influence. What causes a particular disease? How does it influence a particular disease? So also in the determinants is where now we are talking about the evidence for control and prevention. So in analytical or determinants, we also refer to them as the risk factors. Hold on, just 1 minute. Yeah, so that is what happens when we are talking about determinants of a disease. Basically, we are talking about the how and what, and also what influences among others. Okay, so so I hope I'm clear on that, and now you can be able to comfortably describe the determinants and also the distribution. So basically, we have said the keywords when you're describing epidemiology, you are talking about the study of distribution and determinants of health event and status that affect in a specified population, and application of this study in control of health problems. So we have dwelt much on what do we mean as determinants and what do we mean as distribution. Distribution we have talked about to describe, And then determinants, we have talked about the risk factors. Basically, the causation and the influences. So, what do we mean by health-related events? Remember, we are still just on the definition. When you hear in the definition here now, health-related status or event, what do we mean? Health-related events, we are talking about epidemic communicable diseases. Epidemic, we are talking about a disease that is now, it has subdued a particular community, but it has not gone over the geographical boundary. So if we're talking about an epidemic, yeah. So if we're talking about an epidemic, for instance, we say that this malaria has become epidemic. It means that it is widespread occurrence in a particular time. It could be flu, yeah, just flu. You understand there are times when we have flu, all of us are coughing. So it becomes epidemic. It is widespread. We're talking about an endemic communicable disease. So on the other hand, when we're talking about endemic, we are talking about a disease that that is almost it belongs to a particular people of a country. So it is an outbreak in a greater than anticipated what? Increase. So it is actually a little bit more. It is endemic. It has been in a particular geographical area. When you go out there, you come back, you still find it there. For example, you can find malaria is endemic in Western Province. So we also have non-communicable diseases, chronic diseases, injuries. We're talking about MCH, occupational and environmental health. We're talking about health behaviors and outcomes. So all this is what we are talking about when we are talking about health-related events. Epidemic, endemic, communicable diseases, non-communicable diseases, injuries, health behavior and outcome. So basically, we also need to know the difference between a clinician and an epidemiologist, just to understand. So a clinician, it could be you could be the nurse working in a particular healthcare. You could be working in a particular consultation room. So a clinician basically deals with persons, individual person, but an epidemiologist will deal with a population. For example, now we have the Kenyan population who were threatened by the COVID-19. A clinician will rely on the medical history and physical examination to be able to form what? A diagnosis or a plan of care. On the other hand, an epidemiologist will use surveillance, descriptive epidemiology to be able to come up with a plan. Remember, in the descriptive, we're talking about who, the frequency, the distribution, and then come up with a plan, like the ones which you saw with COVID-19, where we were having the hand washing, social distance, also putting on our face mask, and so on. So here you see the difference. Their plan is generated from surveillance. You study the disease patterns over time, and then you come up with a plan. And then we also have, clinician will have differential diagnosis. You have a flu, and then you compare it with another type of a flu for you to be able to determine if it is either a common cold or a pneumonia or any other. So in epidemiology, you also do comparisons. You don't do differentials, but you compare, maybe in Kenya versus US. You can also do that by having analytical epidemiology. So a clinician will also rely on diagnostic tests. They will do tests, while an epidemiologist will try to do analytics epidemiology, where now you are describing the risk factors. You look at the risk factors. What are those risks that when a particular person is exposed to will cause what? A disease. And then for a clinician, they will rely on treatment. There will be treatment, but an epidemiologist does what is called an intervention. No treatment, but intervention, where they will come up with prevention measures and control measures. We are lucky enough to have lived through a pandemic, and therefore we can be able to relate these things with what with the current happening. Okay. So our next objective was to describe the history. I will not dwell much on history, but I will just give you highlights so that you can be able to go, and it is important for you to get this history so that you can understand the genesis and how epidemiology has evolved over time. So the first person who have thought to have contributed to the field of epidemiology was a scientist by the name John Grant. You can be able to go and read on how he was able to come up with the natural and political observations, and was able to come up with bills of mortality and deaths that were caused in London. So he was a politician in London, particularly working for the council. So he was able to see the number of people who are dying, was able to tally those numbers, and was able to come up with observation that we have a lot of deaths among this particular age group. So you can go and read on John Grant. So basically, from John Grant's story, you will be able to get that John Grant, after analyzing or going through this data for a very long time, he was able to show the world that voluminous data can be reduced to few tables. The way you people go to collect data when you will be doing your project, you go and collect data, a lot of data, bulky data, but then you reduce that data into just a table or a pie chart, and it communicates a lot. So that was the lesson that we got from John Grant's story. We also learned the description of data should be brief. You don't put a lot of information where a person can be able to have difficulty in interpreting. So also, interpretation of data should be conservative, meaning you don't have to put a lot of inferences, but should be just be conservative, limited in a particular and geared towards a particular direction. And then also, observing data arising from population can be profitable, because he was able to observe a particular population, collect data, and then analyze and present it into tables and show us which population is dying. And then was even able to push that through legislation. So please go and read the John Grant story. I will not go much. And then also have another person by the name William Farr. William Farr is referred to as the father of modern statistics and surveillance. So he came up, he existed in around 1839, and he became a superintendent of statistics department of the General Registry Office in Great Britain. So I was able to compare statisticians with epidemiologists. An epidemiologist here, we shall see a person called John Snow. So you can be able to see William Farr and the miasma theory. So you also need to go and read about that. You can be able to see how he was able to put them into statistics. So I'm just showing you some of his work, but you need to go and Google John Farr and also read. We also have a person called John Snow and cholera. John Snow is referred to as the father of the field of epidemiologist. So he was able, actually the story of John Snow is one which is actually more significant in this course of epidemiology. The other ones we are just borrowing, but they contributed in one way or the other in epidemiology. So John Snow I can just tell you a little story about him. So John Snow lived in London in about 1854. So in London, there was an outbreak of cholera. So in that cholera outbreak, he realized that people who are getting or fetching water from a particular tap, this tap A, were having a lot of waterborne diseases in form of cholera. And there was another point, pump B, where the people who were taking or fetching water from pump B were found to be having or did not contract a lot of waterborne diseases. So from there, he was able to count, he was able to map it out, the location, and from there was able to assist in curbing cholera. He discovered that cholera, most of the people where the cholera is are people who are fetching water from tap A. While those ones who are using pipe X can be able to see there is less distribution of cholera. So that is the work of John Snow. So he was able to come to look at the water sources in the household of people who died from cholera. So there were several companies from S and V company. 286 people died. In the Lambeth company, only 14 died. Direct from the river, it was 26. Pump wells and unknown to around 4. So from that data, he was able to see or to be able to establish the source of water where cholera is. Yeah. So from there, you could be able to advise and was able to help in that area where he was able to prevent this outbreak of cholera by just being able to follow the definition of distribution and looking at the risks. So that is about the first part, which is basically to define epidemiology, to do the history of epidemiology. So we are going now to talk about other objectives, which are the uses of epidemiology, basic epidemiology, and tasks of epidemiologists. So we're also going to talk about epidemiology and disease. So by the end of the lecture, you're expected to describe the various levels of disease occurrence. We're going to explain the clinical epidemiological triad, to elaborate on interaction of host, agent, and environment, to define disease reservoir, to describe the various modes of disease transmission, to list the use of epidemiology, to describe the basic epidemiological method and tasks of epidemiology, which we are taking it from the first slide. So this is the level of disease. We start, this level goes upwards. So when you're talking about sporadic diseases, yeah, what do we mean when we're talking about a disease is sporadic? Anybody who can be able to say if you know sporadic? We're talking about sporadic disease. Helen, could you be having any knowledge about sporadic disease?
Trial.
Yes,
Trial.
Ocharo.
I think it's when the disease occurs in few places,
Mm-hmm.
or
Mm-hmm.
somewhere
So
specific places.
very good. So it means it's in few places and it is occasionally. Yeah. So it's you just find that there was no disease in a particular area, but occasionally now it occurs. Yes, Helen.
You already answered.
Okay. I thought that you are putting or you are having some other addition or another dimension into it. Maybe you want to give us an example of which, when we are talking about a sporadic disease, what are we talking about in particular?
An example is like maybe we say tetanus.
Mm-hmm.
Yeah, tetanus do they occur occasionally.
Yeah, thank you very much. Yeah, it's okay. It's just occurring. So a disease can start as an occasionally in a particular area, like the way she has told us, tetanus or even a polio, where it can start in a particular area. And then if it is not, the epidemiologists don't take action or you do not report, because there are those diseases which we classify as diseases which you need notifiable diseases. So maybe you don't notify the county, the sub-county, and then now it starts now to increase gradually. So after sporadic, you find now that disease becomes endemic. Yeah. So it started occasionally. Here you can say it is occasional. And then we have endemic. Yes. Any other trial of an endemic disease? What do we mean when we're talking about endemic disease? Any other attempt? Let me look for someone, maybe to just call them so that they put or they help us. Uh-huh. I've seen Aurelia. Aurelia, when we're talking about an endemic disease, what do you think it is, or how does the disease manifest? I've seen some text somewhere. Let me see someone. Yeah, there is a response from Felix, and Felix tells us that when we're talking about an endemic, it occurs particularly in people or a community, particular geographical area. Thank you very much, Felix. That is good. So it could be that polio, or he has given us an example of rabies. There are animals which have been affected or infected by rabies. There was initially one person who had it, or a dog, so it was occasional. And then there were incidences of dog bites within the community. And then we find we have had more people presenting with it. So it is within that geographical area. It has not gone beyond. So it becomes an endemic. And then epidemic, on the other hand, because I may ask you to define these terms, so you need to familiarize yourself with. Epidemic. So epidemic now, it has gone beyond the geographical boundary, but it is limited within a particular country. It has not crossed borders. So here, when a disease says epidemic, it has not crossed border. So if it is in Kenya, it is just within what? Kenya. And then when it becomes pandemic, it has now gone beyond an epidemic, and that disease incidence or prevalence or occurrence has crossed borders. So that is why you find when you're talking about COVID, it was sporadic in Wuhan. It became endemic in that province. It affected people in and around China. Then it crossed border to other neighboring countries up to US and even Kenya and African states. So that is the level of disease. That is why you find there are those diseases which you classify as notifiable diseases, so that we prevent a possible pandemic, epidemic, or endemic. We seek to ensure that it becomes or it remains at the level or the lowest level of sporadic. So we also have the classical epidemiological triangle, which we shall talk more about it. But the classical epidemiological triangle, we are talking about the agent, the host, and the environment. So I'm going to talk about this in details. But right now, know that we have what is called the classic epidemiological triangle, which these three entities are in constant balance. It has to be in balance. Otherwise, we may have diseases which may either eliminate the host. So they interact amongst themselves. So in this relationship of the host and agent, an environment plays a key role. For example, in the course of COVID, you look at those environments that have been able to successfully eliminate the agent to ensure that the host live. So if the environment is a very key factor to epidemiologists when it comes to interventions. So look, when you see the environment, look at it in the context of the balancing or the pivotal role of the environment, between the relationship between the host and the agent. So now let us now discuss about those components in the epidemiological triangle. So we begin first with with the host. So the host influence the chances of disease or its severity. Yeah. So the host, it could be you, it could be me, it could be an animal. So it actually harbors a disease-causing agent. So this host has physiological factors, genetical makeup, the immunological and behavioral factors, which will influence or determine if there will be chances of contracting a disease. For example, if your immunity is low, then you find you will become a very good host to diseases. So the body is weak, it will be attacked, and then we may lose lives. The genetic makeup. There are those diseases which follow genetic lineage. Physiological, the same, and also your behavior. For example, some people may involve themselves in high-risk behavior, which will influence their chance of contracting a disease. Let's say it is an STI. So if a person has multiple sexual partners, then you find that one will go hand or it will influence the chances of getting a disease. So those are called the host factors. In a nutshell, the host factors are factors that influence the chance of getting a disease. Yeah, it influences. We have the agent factors. This one. Agent factors are factors which are necessary for disease. So here we have talked about influence. Here we are talking about necessary. So if a factor is necessary, we are talking about nutrition. So if nutrition is poor, this person will get a disease. Exposure to toxic or toxins, and also if the disease or the agent is infectious. Yeah, so they are necessary. The agent has to be infectious for it to cause a disease. It has to be toxic. It may be transmitted through nutrition. And you have to note that some diseases also do not have an agent. So basically, we're talking about an agent, we're talking about factors which are necessary. That is the key word. Environmental factors, we're talking about things within the surrounding. Or we are talking about the physical. We're talking about physical, biological, and socioeconomic factors. Yeah, so those are called, we can classify them as environment. Maybe physical here, we're talking about dark rooms, we're talking about biological organisms that are existing. Socioeconomic, we're talking about if a person is poor or having, they are likely to have malnutrition and therefore a high likelihood of contracting diseases. So basically, I've been able to tabulate for you here the host, agent, and environment. So host, we're talking about age, sex, race, religion. We are talking about marital status, lifestyle, exercise, behavior, comorbidity, and genetic makeup. Agents, they are factors which are necessary. We're talking about biological, microorganism, chemical, toxins, drugs, physical trauma, radiation, fire, nutrition, that is lack of or in excess. Environment, we're talking about disease, population density, substance in the environment, air quality, weather, noise, food, special environment, hospitals, daycare, and so on. So all those are some of those factors. So an epidemic basically occurs when the host, agent, and the environment factors are not in balance. And you remember that equation or diagrammatic impression which we do like this, and we said this is the host, and this is the agent, and this is the environment. Yeah, so when that is not in balance, it tilts. So there could be an epidemic. So what can cause this balance to tilt? When you are having a new agent, COVID, caused by the SARS-CoV-2, which was not yet there. So when it came, it tilted this balance towards to cause an epidemic. Another thing that can cause this imbalance is when we're having changes in existing agent. I will tell you, we shall define later infectivity, pathogenicity, and virulence. So when there is a change in existing agent, this maybe it was HIV type 1 and now it becomes type 2. So it will tilt the balance because we don't have the medications to cure it. We can also have an imbalance when we have change in number of susceptibles in the population. Yeah. So here among the hosts, so maybe like let's say some diseases which in the yesteryears we said a condition like cancer could only affect the aged. But nowadays we have seen or we have observed a trend where it is now cancer is now shifting from that particular age group to the young age. So it causes that imbalance, and therefore we have an epidemic. We can also have, if the environment changes affecting if there are environmental changes that are affecting the transmission of agent or growth of an agent. So all these factors that I have highlighted here can be able now to tip or disrupt that scale. I hope you are following and understanding some of those factors that can be able to interfere with the that can be able to interfere with the balance to cause an epidemic. And we have said whenever there is a new agent, whenever there is a change in existing agent in terms of pathogenicity and virulence, we shall talk about that. When there is a change in number of susceptible hosts and when there is an environmental changes affecting the transmission. So remember just this thing like this. Environment, this is the balance. We have the host and we also have the agent. So these are the factors which can disturb this balance. So briefly, we shall talk about reservoir. We know we are also, along the process, we are also defining some terms or terminologies. So reservoirs are basically, please allow me to pick this call from another lecturer before we proceed. Yes. Just 1 minute, I sort her out and then we continue.
Was for 1 week and you're told to go back to your various places because of the pandemic. But we thank God that
Can you assist me in admitting this student? So we carry on. So we have the reservoir. Basically, when we're talking about the reservoir, we are talking about habitat in which an agent normally lives and multiplies. So a reservoir could be people. Yeah, it could be people, like Alice Kimani. Yeah, it could be animals, like dogs. It could be environment. So when we're talking about people, a person can be a reservoir of smallpox and HIV. Yeah. An animal can also be a reservoir or a habitat of brucellosis and plague. No, brucellosis is found, when you take milk from animals like cow, which is infected, a person may also be able to contract brucellosis. And you know, plagues is found in, I think, in mouse and rats, which can cause plagues. And then environment, we can also have environment being a habitat for histoplasmosis and also the Legionnaires bacillus. So all those who can be able to find them within the environment, among others. So it is just an example, but you may have a whole host of a lot of conditions which can find and can hibernate or can find a home in the environment. So we have modes of transmission of diseases. Diseases can be transmitted either direct or indirect. When we're talking about direct, we're talking about through contact. Maybe you have come into a contact with a person with anthrax or an animal that died because of anthrax. We also have hookworms, which you can come into contact with the hookworms, and then also have smallpox, which can also be transmitted through direct, through contact. And then droplets, like initially we thought that COVID is transmitted through droplets, where if you are at a meter or a distance of, okay, let me first say, there's a difference between droplet and an airborne. Basically, the difference is in terms of distance. That is what qualifies if a condition is a droplet or an airborne. So if it is a droplet, you will find that a person can spit up to around a distance of 1.5 meters. So if you are within that region of 1.5 meters and you get those those saliva, then it becomes a droplet. But if that condition can go or can infect someone who is at a distance of greater than 1.5 centimeters or more, then we classify it as airborne. So initially in the case of COVID or the SARS-CoV-19, we say we are asking persons to stay at a distance of greater than 1.5 because we think it is droplet, or when we spit the saliva, it can reach that point. But I want to challenge you that those are just hypothetical figures. You know, there are people who are tall, so their projection is longer. So for those people, do we say it is airborne or do we say it is still droplet? Because a person of a height of approximately, let me draw for you here. If this person is about 2 meters in height, the basketballers, and they speak, they can project their droplets at a very long distance. You see this? Very long, as compared to a person who is very short, who can only project it at a very short distance. So the aspect of droplet and airborne should be, as an epidemiologist, you should pay some special attention. So an airborne, we're talking about histoplasmosis, inhalation anthrax. Those ones are indirect. So direct, we're talking about contact, and direct, basically, we are talking about contact, when you come into contact, or droplet. So the other mode, which is indirect, we are talking about airborne, where there are those diseases which are vehicle-borne, meaning they can be transmitted either through food or water. For example, the Salmonella typhi, which can be able to cause typhoid. And then also have vector-borne. The vector-borne are where you must be able to be beaten by some other agent so that it can be able to transmit. So vector-borne, we have those ones which are mechanical because of the appendages, like the Shingella, which has to bite you to be able to cause the disease. And then also have biological, where you find in the life cycle of malaria, those egg, or those disease causing, or the disease causing agent has to mature within a particular animal. So that becomes biological. So the chain of infection, we usually have a reservoir, which we have talked, and then the mode of transmission, we have said it can either be direct or indirect. So direct here, I talked about contact, and I also talked about droplets. Indirect, we have talked about airborne, we have talked about vehicle borne. We have talked about vector borne. Vector. And this is vehicle. And this is airborne. So vector-borne, we have said we can have mechanical and we can have what? Biological. So that is mode of transmission. And then you have the susceptible host, who could be you and me. And then from the susceptible host, again, we can have a mosquito either biting the susceptible host and then now also through a particular mode causing an infection. So this is what, when you're asked to describe the chain of infection, you need to be able to describe this. So I'd like to stop or to end there because I think 1 hour has elapsed. Unless you have any question, you can be able to ask so that you can be able to have another session next week. Kevin Ongwae. Kevin Ongwae. You're saying something? Okay, so because there is no any other question, then I'm going to leave the meeting and we can be able to schedule, I think the other class, we should be having a class on Tuesday, Wednesday, and possibly on Thursday. So you are going to find your attendance, and this one, this discussion, I've also been able to record it. So yeah, that way. So thank you very much for logging and have a nice time.
Excuse me, sir.
Yes, Mutua Mark.
Kindly see, you said next week.
Mm-hmm.
Classes the morning hours, please.
We'll be having classes in morning and afternoon. But we can be able to talk about that through our WhatsApp chat, and let me hear your concern, and then we see on the best way forward. So thank you for bringing it up, Mark.
Since you are here, we can still talk. Because anyway, classes kwa stress. Unapatanga watu tushakunywa maziwa mala. Watu wengine wanaenda kazi.
Sasa anza kunywa uji basi. Anyway, I have heard your concern. So maybe because when I look at your curriculum, those contents are 10 hours each. Epidemiology 10 hours, special 10 hours, and there is also another one which is supposed to be 10 hours. So, and if I look at your timetable for next week, I see Monday, I think it's full. So the places which is free, it is on Tuesday, Wednesday, and I think on Friday. So meaning that if we have the morning lessons, then we will be forced to go to the other week. Is that okay with you?
No.
Yeah, you're here.
Next week.
Because we'll not complete.
Let's finish next week.
Then we'll have to agree to 2 sessions. You have an option of agreeing to 2 sessions or 1 session which will spill over to ile wiki nyingine. So the choice is yours.
I was saying, excuse me.
Yes, Kemboy.
I was saying, on Tuesday, you have 2 morning sessions. Wednesday also the same sessions, and Friday the same 2 sessions in the morning. Will it be? Those are 12 hours.
That will be okay if we can have them that way. No problem with me. The only issue that I may be worried about is when I get the links for the other 8 campuses. But I think I will talk to my lecturers, to my other lecturers who will be able to accommodate them. So that's not a problem. So we agree that we have classes in the morning hours from 8 to around, maybe you can say from 9 to 10, and then from 11 to 12. Is that what you're saying?
I was saying 2 consecutive hours. 2 consecutive
unajicombine zote mbili zinakuwa 2 hours. Hiyo story tunamalizana nayo.
Oh, mnataka tu combine.
Yes.
Kwa sababu some of us have to look for.
I understand you have a lot of you need to get some few coins. Yeah, I know out there it is very difficult. So we'll accommodate you. So I think we are in agreement that from next week we have 2 hours. We combine a session and we call it like that for Tuesday, Wednesday, and Thursday, and I think Friday. Is that okay?
Yes.
It's okay.
Okay, fine. Any other concern? Okay, fine. So nice. Have a nice time, guys.
You too.
Ellen. Abanda aba. Nagimole. Mark.
Ulikuwa umeitwa na mwalimu ukaingia nyasi.
Mark.
Ya ndio.
Ng'ombe Negima.
Mark. Sawa.
Negima.
Ongea na mtu hapa hivi.
Ng'ombe Negima.
Mark.
Nipigie simu.
Mliki.
Ama nikiateka.
Ati.
Ama nikiateka naongea
naye.
Ng'ombe Negima. Ng'ombe Negima.
Ni vita.
Kevo. Hapana si vita. Kevo. Lakini nini?
Mliki.
Ni Simba.
Hebu nipatie niongee naye.
Ndio huyu hapa.
Wewe mtua?
Wewe Mungu, mbona wewe na wewe uko aje?
Unaona ngoja tu mwalimu amalize kufunza ndio ongee.
Hai sasa hii lesson yake inaongea saa hii ni ngumu.
Mliki.
Wewe kunipigia.
Mliki.
Amesema umpigie. Sema Kevo.
Niambie. Niambie.
Sina maneno mazuri.
Ngwe. Umetoweka. Umetoweka. Umetoweka.
Ati nini? Tunangojea bwana.
Umetoweka.
Ngwe.
Yes. Tito.
Uko wapi?
Simba.
Sawa, ukikuja jioni unishtue.
Sawa.
Kevo.
Simba ndani ya group.
Kevo.
Yes, niambie.
Simba.
Mazuri.
Hakuna mazuri.
Yes.
Wako.
Kwani huyu Simba
leo ndio umeamka? Wako leo ndio umeamka? Wako.
Yaani wako hizo siku zote.
Wako. Ndio umeamka.
Tuko kwa moto.
Leo ndio umeamka. Leo ndio unaamka. Wote wanayo.
Ati leo ndio ameomoka.
Wako.
Umepotea tomato.
Sema wako. Hivi. Niaje? Wako. Kwani hiyo kitu unaweka kusaidia nani? Ya Maro.
Alienda hadi akapotea sasa.
Acha upiga.
Kwani unaweka ile ya Maro?
Kwani
sauti ya wako ilipotea?
Kuna tuko kwa Marwa.
Vipi lakini
Muriuki,
cheki
wako amenona uso.
Amenichekesha bana.
Mjitu.
Sema.
Vipi?
Poa sana man.
Kwani na wewe umepotelea huko nini? Kirinyaga?
Wapi?
Kirinyaga ama ni nini utoki huko?
Sasa niko Thika sasa.
Thika unafanya nini?
Nauza mini hoka.
Mutula. Unauza mutula?
Hoka.
Ala, wewe Kevo. Kevo. Kwani ameenda wapi? Kevo.